Yeah. So our first problem is like break a palindrome. So we are given a palindromic string of lowercase letters, and we have to replace exactly one character with the lowercase letter, so that the resulting string is not a palindrome and it is the smallest one also possible. Now we have to return the resulting string. If there is no way to replace a character, to make it not a palindrome, return an empty string. And like A is less than B, lexicographically smaller. If the first position A and B differ, yes. I mean, it's like just example of lexicographical, right? First position differ. For like in this case, you can see this is again both of them are. I mean, they are comparing these two strings, so only this C comes first before this D. That's why this is smaller than this. Yeah. So this is our palindrome string, right? I mean, this is the string that is given to us, which is palindrome. It's A B 336. No, it's not a palindrome. It's a palindrome, right? BBCC. Yeah.
Yeah.
Then why there are oh, we have to break it. Okay. So they're replacing this character, right? I mean, or you can replace this, or you can replace this. So any one of them. This is the most small.
No, no, not any one of them. We need to return the lexicographically smallest one. So that is why that AACCBA comes in.
Okay. I mean, the smallest character we have to replace, right? In the given
Yeah,
string.
so if you look at the ABCCBA, which is given as an input, what
Okay.
the explanation says that there are many ways you can actually make it a non-palindrome. One is the ZBCCBA, and then AACCBA, ABA, CBA. Correct. So these
Yeah.
are three things we can make, but we'll have to choose the only one which is AACCBA.
Because
Right.
that will make it the smallest one. Yeah.
Right, right. So the way they are doing it is they are starting maybe from the left side, correct? And
Mm-hmm.
whenever they encounter any letter which is greater than A, right? So if we
Okay.
actually make that into a different letter of a smaller value, so that should be okay.
So next, I mean, if they find that next character is bigger than the previous one, like why did they replace C with A? Because A will be lesser than C, right? So it will distort that.
Yeah, so you're saying why they didn't take, oh yeah, they have that ABA, CBA also.
Mhm.
Right. So they are trying to do that, but they said that it's like if we have to return the lexicographically smallest one,
Yeah.
then that is the one what we should return, which is AACCBA.
C. Okay. Yeah. Because that would be the smallest one.
Right. Because if you try to return any other thing, I don't think so it works. I don't know,
Right.
but we can try. But that is what it looks like every time. See, whenever you encounter any letter which is not A,
Mm.
and you try to say, okay, if my letter is something like D, just make it lesser by one. Okay, instead of D, make it C. I don't think so all the test cases pass. Maybe I'm wrong, but I'll just try quickly over
No,
here. Yeah, sorry. Yeah. Okay, let me
no,
check.
what you're saying is correct only, I think. Because if you replace it with Z, that won't be the smallest one. Only the smallest one will be this only, A, C, C, B, A. Even because this will also not be smallest because second character is B, right? Here it's A.
But okay, I made that. It should work, I think. Okay, let me check for other test cases if it passes. Yeah, no, so it doesn't pass. Like, see, if you have a test case like Z, four times Z, 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 right? In that case, if you have something like Z, okay, and another Z, and these are four. So this is one test case, it failed. Uh, oh, we lost him. Okay, no problem. Until, yeah, are you back? No? Okay. So maybe I'll just go and start doing that. I'm sorry. Let me come back. Just give me a minute.
Yeah, I got lost actually.
Yeah, yeah, we saw that. Yeah. So yeah, if you actually okay. So what I was saying is now, if we go for some test case like this, right? If I
Okay.
say ZZ and ZZ something like this, four times Z, it
Mhm.
actually failed in my case. And if I say, okay, now I find one of the first character which is not A, and then I just make this as Y, right? And then I make all of these Z's. So I'm literally breaking the palindrome for sure. But what I'm trying to do is I'm just trying to make one smaller than Z. That is Y. So that is not the answer. He says it's a wrong answer, and he is expecting an answer which is like this: A Z Z Z.
Can we just change first node which not equal to A?
Come
Uh,
again?
Yeah, can we okay, we can traverse from beginning, yeah, and if uh, we have character which does not equal to A, we can change it to A. No?
right, right, right. Yeah, that is what actually he's trying to say. But if you look at the problem statement, he says lexicographically smaller, right? So what does that mean? Is if it's a lexicographically smaller, so does not that mean that anything, right? So if you say it's lexicographically smaller than the current one, okay. So it can be anything, right? Because he's showing here A B C D, and that makes sense because ABCD ABCC is smaller than ABCD, correct?
Yeah, yeah.
Mhm.
So if you're showing an example like that, so I was saying that this is my input, right? So if this is my input, then this my output should work, but it's not like that. So they are expecting this one. So this is our expectation. So whenever we have any other letter which is not that of other than A, okay, so you just make it A.
Yeah.
So with the way Nick said, yeah. But that doesn't make sense saying lexicographically smaller, right? Yeah,
Yeah.
yeah. But they didn't mention that very clearly in the problem statement. So, but then it is exactly what Nick is saying.
Makes sense. Yeah.
Yeah. So if that's the way, then we'll have to. But when I ran a test case, then only I come to know all these things, right? So,
If it
yeah,
is, yeah, yeah, I know. That makes sense. I think that is what is done in the code which I have written. If it is not equal to it. Yeah.
yeah, that's fine actually. So what you have implemented might be the right way to do. But I was trying to understand why it is different. You know,
Yeah,
if,
yeah, yeah. That's true.
yeah.
Well, it's the same thing what you said. Like if it is not A, then like I append A at that place. I mean, half part of the string, append A there, and then what do you say? Append the rest half of the string.
Oh, okay.
Otherwise, yeah,
So you are actually going through the palindrome string.
only half because we can distort only half. That's enough,
Uh,
right?
Absolutely, yeah.
Yeah.
And then you go to the half, but whenever you hit any one which is not A, you actually
Insert A
insert
at that.
another A,
Yeah.
okay, at that place. Huh.
And yeah, and if the length of palindrome is one, you return empty as per the condition. Otherwise, in the backs, I mean, you append B at the back end. Like if A is there, right? If you have to distort it, then replace this A with minus B. I mean,
Oh, okay. If you have all A's.
A
Huh.
is yeah, yes,
Okay,
yes.
okay, 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 okay. Yeah, because if you will come out of that for loop if you don't find any other letter which is not A, correct?
Yeah,
And therefore this is a special case you need to handle.
the last,
Okay, either the palindrome size is one, or if it is more than one, and if all of them are A's, then you just add a B to the last.
last, yeah.
Hmm. Yeah. So
Sorry,
this was Leetcode, I think. Yeah.
sorry, I did not get why we add B. Please go here.
Yeah, because there is that example, right? If you go to the example number three,
This one.
correct? Yeah. So if you go to the example number three, he says if you have some palindrome like AA, so then you need to find, you need to make the last A to B,
Hmm.
because here all are A's, right?
Exactly.
I thought we have to change any letter from first part of palindrome. It's what wrong assumption. Yeah, we can change
Uh,
any part, left and right. Yeah.
Yeah, but if you do that, if it's in all AAs, right? If we change even the leftmost one, then it will be a very greater number, right? A greater string value.
because B will come first here.
Yeah, so even if you have a B anywhere, so it's going to be huge. But so I think this is the next minimum value. From
Yeah.
AB, you can, if you just subtract, A will come to AA. But if it was BA, then it will be a huge number to come to AA, right? If you just assume that it's a rolling hash type of
Yeah.
conversion, right? Yeah. So then you'll have to have BA, then something like after that BA will be AZ and AY and all that, and till you reach AB, right?
Yeah.
So AA to AB is only one hop, correct?
Exactly.
Yeah.
If
So
we
that
have only one letter, then why are we returning empty string? We can replace it with any. I mean, that's anyways a single
It's a
letter. Can always be a palindrome. Okay.
yeah, because that's a palindrome. If it's a single letter, any
And
single letter will be a palindrome. So you cannot break the palindrome in that case.
okay. And is this palindrome of -1 plus b? Is it like replacing the last character with b or appending to it?
we are taking only we are taking all the characters but last and adding B.
But last
That
I'm adding. Okay, makes sense. Because all
yeah.
are is okay.
We can move to next
Yeah, this is straightforward
implementation.
problem also. Yeah, right. Yeah, it's more of a rule based. Okay.
Yeah. Oh, awesome. So this is like a string without triple A or triple B. So we are given two integers A and B, and we have to return any string such that S has length A plus B and contains exactly A letters, exactly B letters. And the substring this should not occur in our S, and this should also not occur in our S. So the number of A is given one. I mean, two B's we have to use. Make sure that double A. I mean, this one shouldn't occur, right? So these are
Mm-hmm.
the possible answers. Any one of them you can return, isn't it? You return any string. Okay.
So three A's and three B's are not allowed, but two A's and two B's are allowed. Okay.
Yeah. Exactly. I think that makes sense.
Right. So this is also another rule-based problem, right?
Exactly.
Yeah. So we take whatever the numbers we are given in that input as whatever the values are, and then we arrange them one by one. Maybe we always start with an A. It's not necessary here. You can have any order as
Hmm.
long as we satisfy those three conditions. Okay.
Yeah.
So if we take the example two, if we have four A's, we started with two A's, correct? And then now after two A's, we cannot put the third A, therefore a B was inserted, and then you actually add the other two A's.
So whichever is bigger in number, place them first, and whatever the after that you take the smaller number. I mean, smaller frequency one, and then according to the rules, you just put it at that place wherever it is valid.
Right, right. And also, if you look at the constraints, they are going to be from 0 to 100, and it is guaranteed that such a S exists for a given A and B. So even if you think that if we had A is 0 and B is 4, that won't be a test case.
A is 0 and B is 4.
Right.
No, it won't be because 3 will come now.
Right. So that is an invalid test case.
Valid. Yes, makes sense.
Yeah. So that's not
It's again more of a rule only, like
yeah.
what you said initially at the beginning.
Right.
But like I haven't implemented. Do you have the code? Share.
Okay.
Yeah, sure.
And
Have that. Yeah. Go ahead.
Go ahead.
Please.
Go ahead. Like,
yeah, what is the brute force for this task?
yeah, like which? Yeah, go ahead.
No, I was saying that I didn't find anything as a brute force as such. And really, I was also thinking of how we can do. But if you look at the implementation and the rules, if you follow them, that itself should be a brute force, I think, right?
Yeah, because we are simulating whatever they have said, right? There is no logic. Like we are just implementing what they have said.
Yeah, yeah, yeah.
Yeah.
So
So
that is what I.
do you mean that it's greedy algorithm? Yeah, you
It's
implement
it's
greedy.
greedy, yeah. It's greedy. Yeah. So the way I actually started with, it might be not the very efficient way of doing it, but I started like taking these two flags initially, A and B. Okay, actually they were outside, but then I put them inside, and the reason also. So this is my length of the current string word, what I'm going to return. If this is my RESTful, I'll return. And if both of them are zero, I just return that's an empty. I don't think so there is any test case like that though. But then if it is zero, I start from here and then initially I make them false. And if A is zero, right? So it means that whatever is remaining for B, I need to return. Correct, because I'm in a while loop, I keep on decrementing A's and B. But if I come to a case, these are the base cases, something like that. And if A is zero, then whatever is remaining the B, I will populate and assemble it for that resultant string. Same thing I'll do for B. If I take care of these two things, so then now if my length size when I'm actually going through becomes 2, so we can come to this later. Okay, so if it is not, then I can always say if my A size is greater than B, I will set my A flag to true or else my B flag to true. So I'll always prefer A first. And here I'm doing is like whatever my A flag is, okay, I set one A to this resultant string, add and subtract the count of A. Same thing I do for B and increment my length and then return rest. So only to take care of these three A's, what this is the condition what I look for. Whenever my length is greater than or equal to 2, okay, so I just compare the last length, whatever was it the same, the characters were same. If they were same, then I try to find what character was the last in the last, the very previous element.
Right.
If it is A, then I say, okay, I want my B flag to be true now, or else A flag to be true. So that takes care of in this while loop, right?
Yeah,
So
exactly.
it's a bit of a more coding, but at least it's the same thing uh, what is actually mentioned in the problem statement, right?
Yeah, yeah,
Yeah. So I found someone actually implementing in a better way, and that is what I saw here in a very small way. So he's using same function, okay, and this is the recursive function. So these are the A's and B's, and these are the real characters, and this will be a resultant string. And if he's just looking at if the B value is greater than A, then he's actually swapping it over here. And so if he does that, it becomes very easy. So always looks for, he always assumes that A will be a bigger value. Okay, so they are always swapped based on what is the input. And if A is less than, if greater than 0, we decrement A and then add A to a resultant result, correct? So whatever the A value will be, sometimes it will be A, sometimes it will be B based on this condition. And then
yeah.
if it is, yeah, if A is greater than B, then you actually add A and decrease B, and the same thing you do for the B, right? Return. So it's very neatly implemented.
But what will be the resultant string in this case? Is it like AB, 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 AB?
No, no, it will be okay.
It's like maximum 2A, maximum 2B, yeah, something like up to.
Yeah, like let me try for something. Okay, maybe 4 and 3. Yeah, I think the order doesn't matter as long as that is fine. Yeah. So what you say is right. A, B, A, B, A, or he is also saying the same thing. Okay, if I make it 1, so then
It is an invalid input, right? One.
4 and 1 should be fine.
Oh, A, A, B, A.
Yeah. So you
Oh,
have
does
A and B.
Oh, it's a recursion, that's why.
Yeah, that's the recursion. But the recursion is only when actually the string length is not correct. If B is greater, then only he actually goes recursion and swaps all of the counts for to B and the character from A to B. That's the only thing it does. And afterwards, it's the simple implementation. This one.
So
sorry.
when A is greater than B, he's adding A
Mm-hmm.
and reducing the count of A. So in our case, A is 4.
Mm-hmm.
So it will add like 4 A's to the 3 A's to the resultant string here in the line number 9.
So when he's adding A, okay, so 1, 2. So if he adds 1, but then again he comes to the B also, right? The first time he adds A, okay, then he will add B also. Yeah, that is interesting. So first he adds A. Anyway, he's going to add A. That will be the 1A. Then second time he says another A. So 2A is he's anyway going to add. Correct. So you'll have first A here, and
Hmm.
then you come here. So anyway, you have decremented your initial A here itself before adding.
Is
Okay.
it? Or is it after the while loop it will be decremented? A minus minus will go to the loop. At the
Yeah.
end of the loop, it will decrement.
Yeah. But anyway, he's counted for that. Correct. So he has already counted. But yeah, it will be incremented at the end of the while loop. That is
Mhm.
correct. And here you will come here, so you will have AA. Okay, now even if your A count is 3 here, correct. So then he will add another B, A, B. So your B count actually is maybe we can say 0 now. So 3 and 0. And then when you come here, it will be AAB and your A count will be 2 and 0.
Hmm.
Right. So then you'll come here, he'll still see A is greater than 0. Then he can happily add the rest of the two A's, right? So in
Hmm.
that case, initially it will be something like
So it's
AAB.
having like two A's B, two A's B. Whatever is bigger, if there was like four B's and one A, then he would have added two B's, one A, two B's, one A.
Yeah, yeah. So always 2A he is anyway going to add.
Mm-hmm.
Correct. So this is the first A at this place, and then the second A, and then only one B. So he's making sure he only adds one B after two A's. And the reason why he's doing that is the reason he's actually swapping it here itself.
The
If,
greater one.
yeah, or else then you'll have to follow the whole path, right? If you don't do that, then that will be a huge code.
But I didn't.
What's the question?
I think it's not audible. She's on
Okay.
mute.
Yeah, right. So this is the way, or else then you'll have to do it if it's just a while loop, right? So then if you do it, then these are the things. Yeah, you can do slightly much better, but you'll have to still take care of each and everything, right?
Exactly.
Yeah. So this is straightforward way of doing it, but you see so many if and else conditions, correct?
Totally
So
right.
either you do the smart way this way, okay, which makes more.
That's also easier, like because you have to break the rules, right? So let's first fill everything with the bigger value and then which is
Right,
the
right.
smart value, place it at the point wherever you
Yeah.
find
I
inconsistent.
could have checked here itself. If my A is greater than 2, then I could have placed two A's.
Hmm.
But sometimes it won't be feasible. Correct. If my A is equal to B, at that time it doesn't make sense to put another A there. So because then I'll have to interleave A and B together. There might be some input like that. So I think that what he has implemented, he has implemented with lots of thoughts, right? Or
Hmm.
maybe a lot of experimentation. Then only you'll get a very concise code.
It's actually a standard permutation problem, like where apples are there, oranges are there, and you have to place apples and oranges in an alternate fashion. So there we take the whichever is having bigger in size. Like let's say number of apples is bigger, right? So if there are 5 apples, then there will be 6 places, isn't it? If you want every one apple, one orange, one apple, one orange, like this. So
Oh.
5C, whatever
Mhm.
you the small number. So it is based on that concept.
Okay. Okay. So that's cool. Yeah. Yeah.
Yeah, we can move to next then.
Go to next one.
So our next is like what is this? Okay, number of equivalent domino pairs. So we are given list of dominoes and their dimensions are given, which is equivalent to dominoes. I dimension is this equivalent to dominoes. I mean I and J. CDs that they are mentioned. If and only if A equal to C and B equal to D. Okay, first coordinate of them and B equal to D or A equal to D. Okay. A equal to D also and B equal to C also. Either of them should be equal to any one of them, right?
Mm-hmm.
One domino can be rotated to be equal to another. You have to return numbers of such pairs such that
Mm-hmm.
it should lie within the domino's length and that is equivalent. Domino's I is equivalent to domino's J.
Right, right.
Yeah. Yeah, like if we check this, so this is equal to this and this is also equal to this. This
Uh-huh.
is one pair. This is
Oh yeah. So that will be a pair, and then
pair.
3, 4, 5, 6 don't meet.
One yeah. It
Hmm.
doesn't suffice. So yeah.
So therefore we return only one. So if we had something like another 1, 2 in that case, so we could make almost 3 pairs out of that, correct?
Three comma one. I mean yeah. 1 2 2 3 1 3.
1, 2, 1, 2, and then okay, yeah. So
Yeah.
that will be 3 pairs.
Three pairs.
Okay. And if it was just a single 2, then it will be only one pair. Okay.
Pair.
So
So
here
brute force.
actually,
Yeah,
uh,
go ahead.
yeah, no. So the only thing what we have to look, because we can have multiple pairs of the same values, correct?
Hmm.
And this also. So that is what we need to watch for. Correct. So that's the only trick here. But
To
only
check.
problem will have A, B, C, D anywhere. It will be placed anywhere.
So to bring them closer, you need to sort them, right? So that similar values will come closer.
Hmm.
Like
Yeah,
1 2 is the go ahead, Nick.
yeah. If I just want to add, if we have one more, 1, 2, and also 4, 3, what should be our answer? 1, 2, and 4, 3.
So if 1 2 is there, then three pairs will be there. Like 1 2
Okay,
with 1 2 1 with this, and then again.
yeah. And if
Yeah.
we add 4, 3 now, 4, 3.
4 3, then you have to like these three matches with these three, and these four
Yeah,
matches with this. So one more pair it will increase. Like
yeah.
4 pairs. Yeah.
Yeah. 4. Total of 4.
4?
Right? Yeah.
Why not 5?
No, you have to check this condition, right? Only this will suffice. These two will add extra pairs. No?
So 3, 4 and 4, 3 will make one pair.
Yeah,
Hmm.
1, 2, 2, 1 and 1, 2, which are actually 3, which
Three
are
pairs.
similar. So out of that, you can make 3 pairs.
yeah. And
Total
3
4.
plus 2, 5. No?
And so those will be 3 pairs. And with 3, 4 and 4, 3, you can make only single pair.
Ah, I see. I got
He is
you.
counting is at 2. It's not 2. It's 1 only. I mean,
That will,
pair is 1, right?
yeah, that is a pair, but
Yeah.
that is a single pair.
He was counting the number in a pair 2 comes. So that's what 5 he was saying. Yeah.
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 So
So what is the brute force you said?
brute force, I was saying just normal way, 2 for loops you use and just check this condition. I mean, this matches with, like, take every cell, take its 2 elements and check with all the possible pairs, like where it matches this condition, and you increase your count, right? Like
Yeah.
merge interval kind of, like
Merge interval instead of that, it can be, yeah, in
in,
square solution,
mhm,
wherein you check the A and B and C and D both ways, right?
both ways, yeah.
Yeah, so if you find a similar combination, then you keep on incrementing it.
Yeah.
And but if it is, well, you said you will also sort, right? In that case,
Sort it here, like in merge interval to bring the to check there also we have to check condition whether first value of first interval is lesser than second interval of first value, right? So
hmm,
similarly here also we have to bring those numbers closer, so we'll sort them. If we sort them, then these two things will be together, right? Adjacent they'll be together. And now we can match with the given conditions. If we don't sort, had this value been at this place, then again brute force way we'll have to use.
hmm, yeah, makes sense.
Yeah. So this is what I'm doing here.
Okay, but in that brute force way, actually, getting to the pairs will be slightly not so straightforward, right? Because if you sort all of them, like maybe even if you convert one into 1 2 and then you sort, so you'll have 1 2 1 2 1 2. The previous example what Nick says, right?
Yeah,
1 2
yeah, yeah.
1 2 1 2, then 3 4 3 4, and then 5 6. Correct. So
Yeah.
in that case, if you do run two for loops, which will be an n square solution for sure, and from the top for loop you pick up one element and then you try to compare with the next one, which is another 1 2, right? So
Mhm.
then you form one pair there, right? So that you
Yeah.
call as a pair.
There,
Then you
yes.
move to the next one, that will be a second pair of 1 2. Okay, if we just focus on 1 2 for now, but then when you come to the for loop which is on the top level, again you have another 1 2. Oh, so you'll compare only to the next one.
Exactly. Yeah. So that
Okay.
duplicate shouldn't be. Repeated count shouldn't be there.
So that way it will avoid. Okay. Okay. Then it makes sense. So you already counted two of them. Then you come to the next one. Then you're counting only the single one. So the duplicates won't be there. Okay. Yeah.
So here, like, I'm just creating a tuple. Sorting them first and
Hmm.
creating tuple of values and just segregating in my dictionary. Like if you see it repeated times, so you just count the frequency, right? Like 1 2 pair you saw here, right? Again you saw 1 2 pair. So 1 comma 2 will be your key, and how many times you saw it? 2 times you saw it, right? And now go through each of the values and pair will be what? NC2 formula we have, right? Like NC2. If we have
Yeah,
to select two items out of four, then 4 CT will do. That is equal to 6. So half will do it because we have to take, like, this is NC2 only. N into N minus 1 by 2. That formula it is only to select the pair of values. And just we are adding it to my result.
sorry, I don't understand. Why do we have such formula? Yeah.
So what I'm saying, like, we'll make a dictionary like this, like 1 2. Let's say one more 1 2 was here, right? So we made 1 2, and corresponding to 1 2 we saw two such values, right? And now for
Yeah.
2 1, how many we saw? We saw only one, right?
Yeah.
And 3
Yeah.
3 4 also one, and 5 4 also one. 5 4 also
Yeah.
one. So yeah, now if you use this formula, so these things will be zero.
Yeah. Yeah. But why does this formula works? Why n multiply n minus 1 divide 2?
There is in permutation we have, if n items are given and you have to select pairwise items out of this, so how many possible pairs you can generate out of this? That's like if we go by simulation, let's say ABC is the right. Two pairs you have to select each time. So what will be AB, BC, CA, and again AC will be there, and 3C2 pairs, sorry, 3 pairs we'll have, right? 3C2. Out of 3 items, we are selecting 2 items. So these 3 pairs you got out of this, right? This is equal to what? N into n minus 1 by 2. So 3 items you will get out of this. That is formula what we are using, 3C2, NC2.
Yeah, it's a combination formula. So NC2 will be actually if
N
it
into n minus
comes,
1.
so it will be n factorial into 2 factorial, right? Or n minus 2 factorial.
N minus 1 factorial. N factorial upon n minus 1 factorial.
N factorial upon n minus.
Or I think NC2
No,
it
n
is
factorial upon whatever the number is, like 2, if it
Yeah,
is.
n factorial divided by 2 factorial and then multiplied by n minus 2 also, right?
2. Yeah.
Why? Why multiply by n minus 2?
No, 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 no.
I think it's this much only.
Yeah, I don't remember that. I think I directly remember the formula only. It okay. So this can be, yeah, this will n factorial by 2 only, because n into n minus 1 can be written as what? No, no, no. This is wrong. I think what I've written. It will be like, if you have NC2, it will be like n into n minus 1 into n minus 2. This will be the factorial upon n minus 2 factorial by 2. So this 2 will be deleted and you will get this as a result.
Okay,
Whatever,
so
whatever number you have, that we subtract in the denominator and write the factorial part of it. And then we go till that factorial, n minus 1 into n minus 2. And we nullify these two. 2 comes here actually.
okay, if you look at, there is one thing over here. It
Oh,
talks about.
yeah, I guess I understand. Let's say we have n something. Yeah, how many pair can we do? We can each of them match with n minus one because without themselves, yeah. And we have just divided by 2, but because they are symmetric, yeah, it's easy to remember, and we don't need to remember this formula about
Right, right, that is true.
permutations, yeah.
Sure.
So that is true, but it is n factorial into r factorial and n minus r factorial.
Yeah, your NCR.
Yeah, so this is that NCR formula. So in our case, it will be 3 factorial,
Upon
correct?
2 factorial, yeah,
So 3 factorial divided by 2 factorial,
into 1
and
factorial.
then you will have that 3 minus 1, 2, sorry, 3 minus 2, which will be 1 factorial. So it is not effective here, therefore we don't see that this particular term, correct? So
No, this,
therefore we ignore it.
yeah, 1 we ignored it, yeah.
Yeah. So therefore you actually see it is 3 by, because
3
this 2 factorial goes away with that 2, so it will be 3 by, will
1.
it be only 3?
Yeah, it will be only 3. 3C2 is 3 only.
Yeah. So this 2 will also go away, correct? So this will be only 3. And so if you want to make it more generic, then you can always use this n into n minus 1 divided by 2.
Yeah.
Right.
Yeah, I
So
forgot.
NCR is not so straightforward. We actually assume there are many variants of it, right? So actually
Exactly.
this is the.
Do you guys know the logic behind this formula, like n factorial upon r factorial into n minus r?
Yeah, you are selecting R items out of n items.
So this is the permutation, right? The first upper one, like all the permutation where the order also doesn't matter.
Right.
Right. Yeah.
And so then you have that replacement, correct?
Yeah, because if you write, it will be 6 factorial, but repetition will be there, so we divide it by.
One is a combination repetition replacement, and then you have the permutation replacement, correct?
Yeah, sure.
You want to add anything, Dipal, there?
No, no, okay.
So I'm trying to understand. I don't get that how it is. I mean that
But
derivation.
okay, so that is what the combinations
Yeah,
formula
yeah.
is, right?
I agree to that, but I don't understand that.
It's like ABC is there, right? So
Yeah,
more
I
than
also understand you asking about
AB,
intuition, yeah.
CA, and now if you repeat
But
it
do
for
we
the,
have intuitions for the formulas?
you will have CA. Yeah, that's also we are B. But these things are similar to this only, right? So you need to half them. 6 by 2 you need to do, which comes out to the 3. If order doesn't, in combination our order doesn't matter. That's why we are eliminating this part, dividing by 2.
Okay. Okay.
Had it been permutation, then you don't need to divide by 2 because their arrangement matters. Like B comes first or A comes first.
Yeah. Yeah.
Yeah.
Okay.
That's cool. Okay, so
So this is what we have done till now.
right. So what is your okay? So you're not using any extra space, but you are
Yeah,
sorting it, right?
dictionary I'm using.
Or you are using a dictionary, the tuple.
No, 30, line number 3.
Oh, the D is the dictionary. Okay.
Yeah, yeah. Like that, curly. Python have a very cool tricks now. And if that tuple is repeating, we are increasing its frequency. Otherwise, first time if we are saying you put it 1 over there, right?
Mm-hmm.
And now you go through each of the values and take the numbers out of it, like corresponding to each key, take the key value and just put into this formula. It will give you how many pairs are possible out of
Hmm.
that, and you are done. And just append it to your cumulative sum. I think variable names are not used good.
Okay. So you
Yeah,
still have to use a dictionary and then you are sorting it, correct?
yeah. There
So
might be efficient ways, but I think.
yeah, so yeah, the one way would be like if you are using a dictionary,
Hmm.
uh, the tuple what you are doing because you're sorting, you cannot combine it, correct? So either you convert it into some key value. So where the keys will always, if your initial, the start of any of the domino is small, you make it smaller, and the other you make it larger. If you consider that as an I and J pair, so I should always be smaller than J. If you always change it and make a key out of that, and then you place that as a key. So in this example one, like you have 1 2 and 2 1, so your location of 1 2 itself will be 2, right? So 1 2 will be converted to 1 2 only, but 2 1 will also be converted into 1 2. There you will actually add 2 to your dictionary, so you'll have a count, frequency count of 2, right? So in that case you
Hmm.
can actually use
Get
that.
the.
uh, so you can
Yeah,
avoid sorting, right? Mm.
exactly.
I don't know.
Yeah, I can share my
Sure,
screen.
sure.
I
Please,
did
yeah.
it without sorting. I have just finished when you explain. Okay, wait a minute. Okay, can you see it? Yeah.
Yes.
So I have a map. Yeah,
Mm.
hash map. Then I traverse it, we discuss, and I create a key. Yeah. We know that there is a constraint. Yeah.
Hmm.
That there. Uh, like this. Yeah.
Right.
Okay. Okay. So and I do a key for like this. Yeah. And
Why so?
my A, yeah, because of constraint.
Right, right.
Yeah, we just need to make unique combination. Yeah, for both of them, for both key, for A B or B A to be unique.
Yeah. So the value of the dominoes, I and J, they are only from 0 to 9.
Yeah,
So therefore, he is using that advantage. Yeah. So if you make it both my minimum of D0, D1, so you're always will have a, and also the maximum of D0, D1 for the J, right?
yeah,
I and J, then actually it you don't need to sort it,
yeah,
right?
yeah.
Makes
And
sense.
I push to map and to map, and then finally, as we have just discussed it, yeah, I
That's a
try.
comparator only, right? Line number 8, A comma B points to.
Sorry.
Oh no, what is that? A comma B points to A plus B. I mean, line number 8.
Okay, here, yeah. Oh, it's lambda function. It just takes what
Okay, okay.
it's not a well, let's say such let's write in such way, yeah. uh, x x means what I have what I already have in map, yeah, and y is equal to 1 in my case, yeah, and I just add which I already have in map plus 1, yeah.
So is it the
It's
key value
equivalent
assignment?
to
Can you print the map?
yeah,
Or
yeah. Sorry,
No, I don't think so. Yeah.
sorry.
okay, go ahead. Yeah, you
Yeah,
can explain.
it's similar if I would yeah if it's similar if I would do like this. Uh, map get
Oh, default.
for
Hmm.
Default.
default map, yeah, zero plus one.
Oh,
It's
he's
similar.
adding it that.
Just
Okay.
lambda
Yeah.
function.
Oh, the
So
previous one is adding it. Yeah.
first time if you are seeing, then a zero. Otherwise, next time again you see, then one is added to that, right?
First time will be one, and next
Yeah,
time we
yeah.
will just pick
Just
that one and add
yeah,
one to it. Yeah.
Why is that zero then? Oh,
yeah.
initializing.
That is a different one.
What is X and Y in
Oh,
the map?
It's x and y just the parameters. It's short for it's lambda function as we have
hmm.
uh, in Python.
Yeah, but X will be the we are just updating the value for that key, right? So key you have
Yeah,
passed default as one.
it's like this. Part one, parameter one, part two. Yeah.
Hmm. Yeah.
So when there is nothing, it will just add one. If there is something, it will take it from up and add one.
Why your tabs are in bottom?
Sorry.
Okay. No, like it's a designed word. Your tabs are at the bottom, extreme bottom. That I was asking. How did you get it?
What? Sorry, don't understand.
Like I was saying, okay, go ahead. No, leave it. Like, I mean, the number of equivalent or notepad, all these are in a bottom fashion here.
Oh,
Like,
that you can change it. You know,
okay, yeah. First time, yeah.
can create all.
Uh-uh. Yeah, you can change. Yeah, but this way is a bit short. Yeah, yeah, I prefer this one.
Yeah, that's good.
Just merge. Yeah, thank you.
Yeah, as minor optimization, you don't need a sorting as well as, yeah, the constants are very controllable in this example, right? They are not huge. It's only 4K, but it's still good, right? If 4 into 10 raised to 4, so that length is also huge, correct? Hmm.
4 into 10 is the 4. Yeah. And login will pass, right?
Yeah, and login will pass, but yeah, and also the values of dominoes are only from 1 to 9. Yeah. Hmm. Therefore, you don't need much things there.
Nick is also doing sorting, but in a smart way, like my min and max.
No, no, he's not doing small sorting, correct? So
Min
he,
and max, what is doing?
so he's just taking min and max of the value what he's currently at, correct?
Oh,
So
every that nested
yes,
list is taking min and max value, right?
yeah. So whenever
Okay.
if you get 1 and 2, so min will be 1, max will be 2. But if you get 2 and 1, right? So 2 is before 1. So in that case, also still it will, min will be 1 and max will be 2. So he will add another count to the previous
Yeah.
one,
Okay.
right? That
Yeah.
helps.
Sure.
Okay, so we
Okay.
are good, and I think I'll
Yeah.
stop the recording.
Definitely. Yeah.